Hey guys, so now that we have finished looking at mean, median, mode, and range and the different types of tables that or graphs you can make when analyzing data, such as dot plots and frequency tables and histograms. Now what we're going to do, guys, now that we have that foundational knowledge, is now we're going to take a look into how you can use those different tools to help you look at sets of data or look at different scenarios and see how they compare, see how one might be more reliable, or maybe stuff like which one might be a better option, which one, based on this data, would you choose to use, or if you were to purchase one, which one would you want to have, different things like that. But the point is, basically, what we've finished in this past week is we have finished covering basic stuff. We're kind of getting into the simplicity side of it, in that, okay, let's just do it. Let's just practice how to do it. Let's just see if we can handle how to actually do these different methods, like mean, median, mode, range, finding dot plots, or creating them, stuff like that. And we're going to take another step forward here into analyzing data using different types of distribution, representations, and stuff like that. So, for starters, guys, what we're going to be looking into today is we're going to be looking into creating dot plots from various scenarios, and we're going to look at them and go into discussing, okay, what are some patterns we're seeing with each option? How does their variability compare? And variability is going to be one of those things we get into some more today, and we'll discuss that here in just a second, what we're talking about with variability. But let's just go ahead and start by getting into the dot plot aspect of it, guys. So the notes that you're going to have for today's lesson should look like this one here. So this one here says lesson 8 at the top, and they give you a table here that shows 5 different brands, in this case, of jelly beans. And so let's just take a look and read this section up here, and then we'll get into what we're going to do. So the sheet says that distributions can be ordered according to how much data values vary around their means. Okay, so let's just start with that sentence. So what they're saying there is that you can look at different data plots and see, okay, based on how much my data varies, in other words, based on how different it is, how far away it is from the mean, could be one way to order them. And so, for instance, if I had a mean and it was, I don't know, 5, and I wanted to look and put them in order and see how they vary based on that, well, I might go from the ones whose dots on their dot plots are staying the closest to 5, and then work my way out to the ones that are having dots on their dot plots that are getting the farthest away from 5. Because maybe we're relying on the mean to be a reliable way to analyze our data, and we're saying, okay, if I think that average of 5, for instance, is a good indicator of my data, maybe I want to order them based on the ones that stay closest to it, and then not really take as seriously the ones that are have dots that are further away. And we'll talk here in just a second about what that's going to look like. I think the representation that we get on our sheet today will help kind of clarify that a little bit more. I think a visual does a lot better job to help clarify that. So let's just keep going with what it's saying. So then it says, Consider the following data on the number of green jelly beans in 7 bags of jelly beans from each of 5 different candy manufacturers. And then they tell you the 5 candy manufacturers for the jelly beans. You have All Good, Best, Delight, Sweet, and Yum. So clearly they're using some kind of catchy name to be like attracting people in, which it's a business idea, right? So if you're wanting to sell something, you're going to give it some kind of catchy name that's going to make it where someone's like, huh, that seems like something that I would like to have that would be appealing. And if you're trying to get jelly beans, of course, you're going to want the ones that taste the best. So they're going to give them names that are going to attract you to think that they taste good. So then it finishes off by saying the mean in each distribution is 42 green jelly beans. So here's what they're saying. They're saying that you have 5 different options for jelly beans. You have All Good, Best, you have Delight, Sweet, and Yum. And they're saying if I took the 5 numbers, if I took the, looks like 7 numbers related to each one, so the 7 bags for All Good, the 7 bags for Best, and I took the mean or the average of those, then they would all end up being 42. And as you can see, some of these numbers stay pretty close to 42, and some of them stray a little bit from 42. But the point is, at the end of the day, they're all going to average out to 42. So either because the numbers are all staying close to 42, or maybe there's some numbers that are a little bit below 42, but there's also some other numbers in the list that are a little bit above 42. They kind of average it back out to where it kind of meets in the middle at 42. But that's really just what they're saying. They're saying no matter what numbers you see on that table, every single brand of jelly bean, if I average their 7 numbers, gives me an average of 42 or a mean of 42. Okay. So that's the scenario we have so far. So we know that the average for every one of these brands of jelly beans has to be 42. And we're going to see how consistent the numbers are sticking to that average of 42 by making dot plots for each one. So it says on number 12, draw a dot plot of the distribution of the number of green jelly beans for each of the 5 candy makers. Mark the location of the mean on each distribution with the balancing symbol, and the symbol is shaped like a triangle. So what that's saying here is after you make the dot plot for each brand of jelly beans, go ahead and put the little triangle symbol, the triangular symbol at the 42. And just use it as a reference point when you're looking at the dot plots to see, okay, how close are these points or these dots sticking to the mean? And so one little detail here, guys, before we get going on this, some of y'all, when you're editing this document, and you should be able to edit it on with the links I give you on Google Classroom, but with the text box situation here, I think what I'm going to go ahead and do is I know that if it says dot plot, you typically need to use dots. But remember what we said, line plots work essentially the same way. It's just instead of using dots, you use X's, right? So since we have text box options on the document, or you should with the document I send you, I'm going to just go ahead and instead of marking dots, I'm going to mark X's instead. Because quite frankly, guys, it really doesn't matter because line plots and dot plots are showing you the same information. But just so I'm writing it in a way that it's possible for you to follow along with and write down, just in case you can't get like an option to draw dots in your notes or something, let's just stick with X's for today's dot plots. Okay. So if you get a little confused about why am I not using dots, that's why. We're just going to stick with the X's because the X's work the same way as dots. So guys, let's just look at the first situation. So if I look at my sheet here, it looks like the first option is the All Good brand. So all I'm going to do is I'm going to make a dot plot for the All Good brand using the data they give me on that top row for All Good. So I'm just going to put an X every time I see these numbers on the top dot plot for All Good. And remember, guys, if you see more than one, you stack them another X on top of it until you have as many as the number showed up. So if there's two, you have an X and then another X above it. So let's just go through the list here. And they appear to have done us a favor on this first one, and they have put it in order from least to greatest. They go 40, 40, 41, 42, 42, 43, and 46. So that's kind of a good thing, and it's going to make this a little less complicated. We're not going to be having to go back and forth trying to find where to go, and it'll be a little easier not to mix it up. But let's just go ahead and start by making a dot plot. So I see a 40, so I'm going to put an X at 40. Okay. Then I'm going to put another X at 40 because I have two 40s. Okay. So far, there's my two 40s, X and an X. So here in a second, I'm going to cross that 40 out and that 40 out. Because remember, it's always a good idea just to cross them out once you use them. That way, you don't get mixed up and use them again. Now, keep in mind that, guys, from here on, we got 41, a 42, a 42, a 43, a 46. Well, notice on my ranges, they don't show those exact numbers. And guys, a lot of times on a dot plot, they'll give you every possible number here on the bottom. But if you ever have dot plots where the range gets a little more, can maybe be more spread out, or maybe they just chose a different way to express it, it's never wrong to use skip by numbers. And they skipped by, it appears to be 5s on these, and that's okay. But keep in mind, we're going to have to kind of estimate the right spot to put them if they ever land in between two numbers. And in this case, it looks like most of these up on the top, guys, are going to land in between 40 and 45. So keep that in mind when we finish these dots. So the next number, I'm going to go ahead before I forget and cross those two 40s out on All Good. And the next two numbers appear to be, well, the next number appears to be a 41. So I'm just going to go ahead and put an X right beside the 40 and cross it out. Because I'm going to put an X anywhere. 41's going to have to be directly to the right of 40. So I'm just going to put that X for 41 right there. And I'm going to kind of rinse, keep going with that, because the next option is 42. So I'm just going to have to put another X immediately beside the 41 to make a 42. So there's my next X right there. I'm going to try to write these a little bit smaller so I don't get so bunched up on the next few, especially now that I'm doing X's instead of dots. It's a little easier to do it with dots because it doesn't take up as much room, but that's okay. We'll just write it a little smaller so that it all fits just right. Okay. So my next number is another 42. So I'm going to put another X on top of that. Cross it out. And then the next one is a 43. So I'm going to put that down. And again, they do us a bit of a favor this time around. And they go ahead and put it on just one more above again. And I'm getting a little low on room, but that's okay. We're just estimating here. So there's my 43. And I only have one left. I need to fit in that 46. Well, if it's 46, it should go just barely to the right of the 45 to be 46. So with all 7 of them on that first dot plot, it looks like it should look something similar to this. Now, I probably could have scooched that over just a little bit more in this direction here just to kind of squeeze it in a little better, but it's okay. It's close enough. It's an estimation. It's not a big deal. So then what I'm going to do is I'm going to put a triangle above the mean. And since I decided that my 42s were going to go right here on this stack right here, I just put another one right there. So if we look here, if this is the mean at 42, it appears as though these numbers are staying pretty consistent to that mean. If it's 42, the farthest away it gets is a 46, which is just 4. So that seems like it's not varying too much right now. But maybe we'll find some dot plots that stay closer to the 42, or maybe this first one, all good, maybe it's going to be the one that has the least variability. Maybe it's the one that's going to be keeping its data points closest to the average, in other words. Okay. So I'm just going to keep going with these. So I'm going to make a dot plot for the next option. So if I just follow my table down, my next option appears to be best. So on best, I'm going to make its dot plot right here. And again, it should be pretty self-explanatory at this point. I don't think we need to just go through step by step how to do these. Dot plots are pretty simple. It's just a matter of making sure to estimate, and we're pretty good at estimating. So I'm pretty confident you guys will be pretty good at estimating your spots. But if you have any kind of questions about it, just take a look at how I wrote it. See if my idea makes sense how I represented it. But if you have any questions, please feel free to message me about it, guys, because I want to make sure we're all on the same page on this stuff. Okay. So I'm just going to start here. On best, the first number is a 22, which means it should go somewhere in between 20 and 25. Okay, cross it off, and then I get a 31. And it looks like, before I keep going with that, I'm just going to go ahead and mark the 31, which will be just to the right of 30. But it looks like they've actually done a favor for us on all 5 of these dot plots, and they've put them all from least to greatest. Which is nice because it's keeping us from having to kind of get mixed up and forget a number. But again, just remember, as you graph these, make sure to mark off your list. So the next number is a 36, which should go just to the right of the 35 on the number line. And the next is a 42, which should go somewhere close to the middle between 40 and 45. Cross it off. Then 48. Well, according to the number line, 48 should go somewhere pretty close to the middle between 45 and 50. Maybe just a little closer to 50, though, because since it is just slightly closer to 50. Then the next one will be 53, which would be between 50 and 55. Maybe just a hair closer to 55, if you're estimating. And then the last one is 62, which should go pretty close to the middle between 60 and 65, but a little bit closer to the 60. So here's my dot plot for best. Now let's go ahead. Remember, your mean is 42, so I'm going to go ahead and put that triangle above that 42, which again, conveniently enough, they gave us a 42 to mark with an X. So let's look at this one. If I'm trying to look at variability here, think about these two right here. This dot plot is staying, the dots or the X's, whatever you want to call it, stay really close, it seems like, to that average of 42. But look at this one. Look how spread out these X's are getting. Clearly, we don't seem to have as reliable of numbers if we want to say the average is 42. Clearly, there's some numbers that you would get on this that you wouldn't really be expecting if all you were told was the average was 42. Like if you got 22 or 60, if you have 22 or 62 on this, that is not going to be something I would expect if someone told me the average is 42. But just keep in mind, it doesn't mean it's not possible. It's possible to have numbers that are a lot bigger or smaller than the average, as long as there's enough on each side or big enough ones on each side to average it out. Okay, so if I'm talking about variability on this dot plot for best seems to have a lot more variability than this one. And again, here's what we're thinking about with variability. The closer numbers are to their average, the less variability they have. The farther away they are from their averages, the more variability they have. So it seems like the option for best has more variability than the one for all good. So we're just going to keep going with this. The next one's Delight. So the next dot plot we'll do for the Delight brand. And it gives me a 26. I'm going to mark that and then cross it off. And then a 36. Already seems like this one's going to kind of deviate or have more variability again compared to the first option at all good, since we're already starting at 26, right? That's not near as close as all good was getting. But let's just keep looking and see what it ends up looking like when it's all done. You don't ever want to jump to too many conclusions until you see the whole thing. So I'm going to finish it off. Let's say I got a 40. Well, that's a nice, easy one. It's going to be right on top of the 40 on my number line. Okay, not a 42 on this list. There is a 43, though. And then I see a 47, a 50, and a 52. And before I finish this thought here, guys, keep in mind, these notes that I'm filling out right now, they are on the Google Classroom page, and it should be on there. And one of the links I'm going to send you are going to say notes, and the other one will say homework, which will just be the assignment you work on. So if you have any issues with those links, guys, please let me know. But if you're needing, before I continue with this, just so you're not getting behind on this, if you're needing the notes, you're not sure exactly again where I have these, it's on the Google Classroom page. Should have the date, a link that has the date on it, and notes. So I'm going to go ahead, guys, and put another triangle where the 42 is supposed to go. And then I'm going to take a look at delight. Really kind of take a look at all three so far, because what I'm doing here is data analysis in the sense that I'm comparing data sets that have the same mean but different numbers that got them that mean. Because it's clear that all of these, even though I mark their means in the same spots, they all use different numbers that gave them that average. So if I look, delight, if you're comparing its variability to best, it has less variability than the best has, because the best is more spread out, which means it has more variability. Delight is spread out, but not as much as the best one is, right? And if I also compare delight to all good still has less variability than delight, because all good is still staying closer together. It's staying more towards that mean. So in other words, that mean is still seems to be more reliable on all good than it does down here on delight. Because again, if I told you that the mean was 42 and you see what appears to be a 26, you're not going to expect a 26 when the average is 42. Neither are you going to expect a 52 if the average is 42 as well. So there are definitely extremes on both sides here that wouldn't be totally expected when dealing with means and dot plots. So that's what we have so far. So let's wrap it up by looking at the back. So on the back, and this should be the second sheet, it should still be on the same link as notes. I try to put both pages on that slide, Google Slides doc. So if I look, I still have the two dot plot diagrams for sweet and yum. So I'm going to finish those off and answer those two questions below. And then we'll be ready for our assignment. So on sweet, I'm going to again use the table and make the dot plot for sweet. Looks like I got 36. And then I have 39. So right in front of 40. Then I got, okay, here we go. We got some 42s this time, and we actually have what appear to be 3 of them. So at 42, I'm going to stack 3 X's on top of each other. 1, 2, 3. And I'll cross those off. And just to show you, there's the 3 X's, 142, another 42, and another 42. Okay. And then I got a 44 and a 49. So now I completed the dot plot for sweet. Oh, and one last thing that we forgot. We did not mark the mean with a triangle. And this one will be easy to find because the mean, that triangle will go right above the biggest stack on the dot plot here. So if I look here, if this one looks a little better, the sweet option looks like it's staying a little bit more consistent with the mean. And if I look at the numbers, 36 is not the closest to 42, but it's better than like 26 or 22. 36 is still closer there. And if I look at the biggest one, 49's a little bit away from 42, but it's better than 62 or 52 if you're trying to stay close to the mean. So let's just try to pull these all up so far, what we have. So if I look at what I have so far, how about we do this? We'll just kind of put them and compare them. So if I compare sweet and the delight option, it looks like sweet has less variability. It looks like it's less spread out than delight. So it looks like sweet's more reliable there with the mean. If I check on the next one with best, again, sweet is staying closer to the mean. All of its x's are staying closer to the mean than best is. So I still think that it has more reliable numbers when you're relating to the mean. But if I go one last time and try to compare it to all good, while sweet does a pretty good job at staying close to the average of 42, it doesn't stay as close, it appears, as all good does. So while sweet has pretty close numbers to its mean, they don't stay as close as all good. So it looks like all good still has less variability than sweet does. Okay. So sweet got close. This is really the first time one of the dot plot options has gotten close to all good as far as having less variability. The other two options, delight and best, really couldn't compete too much when you compare it to sweet. So let's look at the last one here, guys. So the last dot plot is yum. And on yum, I'm going to go ahead and mark them. I got 33. And then I have 36. Okay, I have a couple of 42s this time. So I'm going to stack them on top of each other. 42, 42. And then I have a 45. And then two 48s. Mark all those off. And again, make sure I check myself. And I should have mentioned this a little bit before, guys. But make sure when you're doing these that you count your X's or dots, whatever one you want to try. Honestly, it's technically more accurate to do dots on this, but if you did dots or X's, doesn't really matter as far in the grand scheme of things when you're trying to analyze these. So just make sure you have 7 of whatever one you chose to use. 7 X's, 1, 2, 3, 4, 5, 6, 7. As long as you have 7, that means you haven't forgotten any of them. So just make sure you have done all that. Okay, so guys, when I'm looking at these, now that I get to the last couple, it appears that I'm getting pretty close here when I'm looking at these data distributions. And really, when I look at them, yum stays pretty close with sweet. If I look, they're almost the same at the end of their tables, which should make sense. Which should make sense because the largest number on sweet is 49, while the largest number on yum is 48. So they're almost identical there. Now, if I look over here at their smallest number, sweet's a 36, yum's a 33. So it looks like yum's just a little bit more spread out than sweet is. And also, sweet has 3 42s compared to just 2 42s on yum, which would also kind of help your variability with sweet simply because it's got more numbers that follow the mean. And like I say, it's just there isn't much difference in the variability between sweet and yum, but sweet is just slightly closer together with its data points. So I still think that sweet has less variability than yum does because it's just a little less spread out. And since we've decided that yum has more variability than the sweet option, and sweet had more variability than the all good option, I think it's safe to say all good overall had the least variability of these 5 options. Okay. And we're going to keep that in mind here when we answer these next two questions. And these two questions should help set you up for the assignment. So if I take a look at the two questions here, we're going to look at 13 and 14 here, guys. So on 13, it says order the candy manufacturers from the one you think has the least variability to the one that you think, to the one with the most variability. Explain your reasoning for choosing the order. Well, we'll just go ahead first and just kind of go, and we don't really need a whole lot of explanation here, guys. If you want to type more explanation, please feel free. But I think it's okay to kind of keep it a fairly simple explanation because variability doesn't have to be a complicated idea. So the first thing they want you to start with the least amount of variability. Well, just throw up my 5 dot plots here real quick. If I look at my 5 dot plots, let's try to fit them all on here. Again, I think we've all concluded that all good has the least variability. So I'm going to put all good first because they want you to start with the least variability. And I'm also going to go ahead on my paper and write down least, and then put all good below it. And on the other side of my paper, I'll put most. So far on 13, I wrote least, put all good, and then over here most, because we're gonna work our way over to most. So I can go ahead and honestly, guys, it doesn't really matter how you go about this order. I'll just kind of stick with what we've really been following along with, just to kind of help this make the most sense. So if you remember, when I was going through these, okay, we've already used all good. We've already used this one right here at the top. We haven't used any of the other ones yet, though. So if I look at them, though, remember, these two are really spread out. Best and delight were super spread out compared to these over here. So we're going to be using these two options, the sweet and the yum option, next. Now, remember what we were saying. We want the least variability first. So we decided sweet was just a little bit less variable, or it varied a little bit less than the yum option. So I'm going to put sweet as the next least variability, and then I'll put yum. Okay. So I'm going to put sweet option, and then the third most, or the third least, I guess technically the same thing in this case, since there's 5 of them, but the third least variability was yum. So far I have all good, sweet, and yum. Okay. Got 2 options left. Well, I am down to delight and best. If I want the least variability, looks like delight has less variability than best since it's not as spread out. So I'm going to have to put delight as the one with the next least variability. So delight. And that means that the last, or the one with the most variability, in other words, the one that's really, if you're trying to use mean to determine what to expect, ironically, the one that's least reliable is the option that's called best. So, maybe there's a reason behind why they name it best. Maybe they know that the company's not very good at keeping it consistent as far as how much you're getting. So they're just going to go ahead and name it best so that they just kind of suck you into thinking, oh, well, they call it the best. So it clearly is going to be my best option. And honestly, sometimes in business, it just takes a nice little pull-in kind of name like that to just get people to fall for it and then not even think another second thought about it. But honestly, if we're just going to try to get to the point with this, if I'm looking at best, let's think about something. I'm wanting to bet jelly beans, and any person that's buying something is most likely going to want the most they can buy for the least amount of money. Or if they're going to spend the same amount of money on something, they're going to be wanting the one that gives them the most of it. Like if I'm going to spend $5, I want to get the most out of that $5 I can, right? So let's just throw up a random price for a box of jelly beans. Let's say it's $5 for a box of jelly beans. Well, if I'm looking at best, if someone told me, oh, by the way, the average number of jelly beans you can get in this box is 42, like, all right, that doesn't sound too bad. But again, if I'm looking at this and it says, oh, well, that doesn't really follow what this dot plot's saying, because according to this dot plot, what if I'm the unlucky person that got 22 jelly beans? If the average is 42, that means I only got about half a box of jelly beans, and I wouldn't want that. I would want way more than that. If I'm going to buy a box, I might as well get my money's worth out of it. Now, you could have this mentality. Maybe you're like a risk taker and you're saying, well, okay, but I could also be that lucky person that gets 62 jelly beans because it's an option too, because they needed that larger number to keep the average right in the middle with that low number, generally speaking in those terms. But maybe that's all right. But to me personally, I would rather not risk it. I would rather want a company that's reliable. And to me, I'd rather not be getting cheated out of what I'm buying too many times, even if there is a chance of getting more. So here's a situation where knowing the mean does not help you too much if you're looking at best, because you're just getting numbers that are way too spread out from the mean. If you look, really, these three dots in the middle, or X's in the middle, are the only ones relatively close, but the other four dots or X's, whichever one you use, are pretty far away from the mean, so I don't think it'd be a very useful option. So in this case, variability, a lot of times you want more of something. You don't typically want more variability, because more variability typically means that your numbers are not staying close to the expected amount. And in this case, you're trying to use mean as the expected amount, and it doesn't seem to be helping. So another way to look at it, though, is if you look at the other option, the least variability was all good. I would like to buy something like all good, because I'm not really too concerned about whether I get more or something. I'm more bothered if I don't get what I paid for. And I would rather just pick a company that gives me what I know I'm paying for. Now, everybody's different. Everybody's gonna have their own preferences. But to me, I would like something like All Good. Because with All Good, if you look at your data, yeah, you had a 40 in there, but 40 is, if I was told, okay, expect 42 jelly beans, and I got 40, I wouldn't be too upset about that. It's only 2 jelly beans. It's not like I'm missing 20 of them like I am if I had 22 on the best option over here. So to me, I wouldn't mind it. I can be okay with missing 2 jelly beans, and it's okay if I got 46, because I mean it's a little bit more, but I'm not too worried about getting if I get way more, because as long as I'm getting close to what I'm expecting to get, me as someone buying it wouldn't be too upset about it. So in this case, this is showing me why the least amount of variability is a more reliable choice. So just to kind of finish the explanation on 13, and we've basically already answered 14, but just kind of wrap up 13 here. Explain your reasoning for choosing the order. Basically, a pretty simple explanation. I'm just going to describe two things. I'm going to describe all good. I'm going to describe best. And for all good, simply I would say it has the least variability, because I would say the data points stay closer to the mean. I was going to add of 42. on all good, I'm simply going to explain it as the data points stay the closest to the mean of 42. That's why it has less variability, because it's staying closer to the mean. And then for best had the most variability, and I'll just kind of write the opposite for the explanation, because the opposite's happening. Instead of data points staying closer to the mean, I would say that the data points are farthest away from the mean. And then I'm going to add one more idea to that. I'm going to put in parentheses that they are also more spread out. And if we remember from last week, spread is another way of saying range. So like the difference between the biggest and the smallest number. And I'm just going to go ahead. I don't think I need any more for an explanation on least variability. But yeah, there's what I put for best. I said the data points are the farthest away from the mean, and I just wrote that they're more spread out. Okay. Again, just think of it as the closer they are, the less variability they have. The farther or the more spread out they are, the more variability they have. Okay. If I look at the last question here, it says, for which company would the mean be considered a better indicator of a typical value based on the least variability? Well, there's a nice clue there. It says in parentheses at the end of number 14 that it's based on the least variability. So that's kind of telling you right there, it's probably pretty safe to say the least variability leads to more consistency when using the mean. So if they want the company that's considered a better indicator, where the mean's a better indicator of the typical value, well, a typical value just means if I just picked a random number out of those 7 numbers that you use in the dot plot, would the mean of 42 be a nice clue to what you're going to get? Well, we just talked about that. As I said, if you want the mean to be a good indicator, or you can think of an indicator as a good predictor of what you're supposed to get, I would say that all good is, again, the best indicator with the mean, because all good's points stay really close to the mean. Therefore, all good using mean would be a good indicator for it. Since every number stays really close to the mean's a really good predictor or a really good indicator of what you're going to typically get with all good brand jelly beans. So I would just simply put all good. And again, there's not really much of an explanation for it, because we already explained it on the previous one that it has the least variability because it stays closer to the mean. But I'll just go ahead and add something. I'm just going to say all good because all of its data points stay pretty close. I'll say pretty close to the mean. And that's a pretty good way to explain that. So all good works best with the mean because all of its data points stay pretty close to the mean. And I'll go ahead again and add the word of 42. And that's really all there is to say about this one. So again, guys, what we've been looking at here today is simply taking data, in this case dot plots, and really we didn't even have to actually find the mean today, because they did us a nice favor here and they just said, hey, here's the mean. We're not even going to ask you to find it, but we know how to do it because remember, mean, add up the numbers, divide by how many you have. In this case, there were 7 data points, so you would have divided by 7 if you added them all up. But regardless, the point was showing us how can we use mean and variability to figure out if mean is a good indicator of what you should be expecting, or again, indicator, predictor, same idea. So guys, for your assignment for today, what you're going to be working on, it should be the sheet that says exercises 8 through 14 at the top. But you're not going to do all 8 through 14. You're just going to do 8 through 11. So, and honestly, the reason we hadn't even done 12 and 13 and 14 is because that was the notes for today. So you've actually done 12 through 14 already, but your assignment is going to be 8 through 11. Because I see this problem as being a pretty good test to see, okay, how well did you understand what we're doing today? So just to kind of read through it, it says exercises 8 through 14. Consider the following 2 distributions of times it takes 6 students to get to school in the morning and to go home from school in the afternoon. And again, before I keep reading this, guys, if you're wanting to know which sheet we're looking at, just kind of follow along. It should be on the Google Classroom page. When I upload it, it should say 4-6 2020 homework. So if you're wondering, or if you want to follow along with what it's saying there, if you're a little confused where we're at, you can go ahead and pull that up real quick. Just pause this and take a look at it and just follow along with what we're saying. So again, it says consider the following 2 distributions, so 2 sets of data of times it takes 6 students to get to school in the morning and to go home from school in the afternoon. So it gives you 2 options. You have the morning option and the afternoon option, and they give you 6 numbers for each one. And then it says to visualize the means and variability, draw a dot plot for each of the 2 distributions. So you're going to do just like we were doing on today's notes, guys, when we were looking at the different variabilities. So you're going to make a dot plot on number 8, make a dot plot for the morning numbers, and make a dot plot for the afternoon numbers. So it is similar to this. Make like 1 dot plot here for the morning on your sheet, not this one, but same idea. You're going to have 2 dot plots, and you're going to be comparing them, okay? And then you're going to make 1 for the morning, 1 for the afternoon option, okay? Then what it's telling me on here is to ask you 3 questions. Honestly, I don't find any of these to be too bad, but I think it'll be a nice challenge for us. So it says, what's the mean time to get from home to school in the morning for these 6 students? I don't think we'll have any issue with that. We know how to find the mean. And on number 10, it asks, what's the mean time to get from school to home in the afternoon for these 6 students? Well, you should have all the data you need to find the mean on number 9 and number 10 in that table, okay? So use that to your advantage and find the means. And then it says on number 11, for which distribution does the mean give a more accurate indicator of a typical time, and explain your answer. Honestly, guys, we answered a question pretty much identical to that on the notes today on that last question we talked about, number 14. So you should have a pretty good clue of how to answer that question. So I don't think that needs any kind of extra, oh, let me give you this little tip before you try it. You shouldn't have any issue with number 11. Really, I don't think any of these questions are a stretch for us. I think we're pretty capable of answering all those accurately. And again, guys, when you're doing this sheet, if you can make, I'm not totally sure about all the options on how to write on the sheets, but I know from experience that you can type, if you want, guys, just type X's in the text box on your dot plots on number 8, and it should look pretty close on a dot plot. Just try to just use your space bar just right, and you should be able to use X's and stack them on top of each other and make an accurate looking dot plot. If you can make it work with dots, be my guest. That would be great. But just know that I have no issue with you just typing X's in the text box to help you create your dot plots for these two options, because it gets the same ideas across, so it doesn't have to look just like a typical dot plot. I'm cool with using X's. Say we are trying these new ideas here, guys, and I don't think there's any issue with just making a line plot instead of a dot plot by using X's, so why not? So you'll still get the same kind of information. You'll still be able to visualize your dot plots. You'll still be able to look at the patterns just like we did in the notes today. So just kind of keep that in mind when you're doing that, guys. So like I say, the homework sheet, make sure you get that submitted as your assignment for Monday, guys. I don't think it shouldn't take you too long, guys. We know how to find mean, and I think today's lesson was a pretty good descriptor on variability. So that being said, guys, that's about all there is for today. Let me know, guys, if you have any questions about the notes, the explanation I gave on it. Hopefully, now that we have hard copies of the notes, it's going to be a little easier to follow now. I know it was a little different last week without me having hard copies of the notes, but I think it'll be pretty helpful now that we have copies to work with. So if you have any questions about today's video lesson or an explanation I had or anything on the notes that you didn't quite understand, please message me about that and I'll be happy to help you. And then just make sure that you turn in again the homework link that I send you. One will say notes, one will say homework. Please I'll make sure everyone has their own copy to type on. Make sure you get it to me. However you submit it to me, one way or the other. And also the quiz grade, I have all the quizzes that I have a grade for that was on the report. I'm pretty sure everyone's in there. If I didn't have it, I will be messaging you about it. And I want everyone to have an opportunity to take this quiz. I know things happen and sometimes we're away from our computer for a bit, especially with it being the weekend. And I know this is a new thing. So remember, if you did not get a 70 or above on that quiz, I want you to try and take another look at it. Because quite frankly, guys, the most important thing is that you understand what we're doing. And if you aren't getting above a 70 on something, then I think it would be more beneficial for you to try it again and keep giving yourself a better idea of what we're doing. So please do not accept that a failing grade on the quiz. Keep working on it. If at this stage in the game, guys, it's more important that we understand the material. And if that means you having extra opportunities on the quizzes, I would rather see that you've learned it. That's the more important thing to me. So I'll be getting back to you guys on that. I should have all the ones graded for now, like I said, but we'll be clearing that up tomorrow. I'll be, like I say, if you have your quiz turned in, you should be good. If you turned it in and I just didn't see it and I messaged you about it, just tell me and I'll look and see if I missed it. But if not, just please make sure you take it. I'll open it back up for you to take. And so everyone will get a chance to finish it and give it an honest effort. So that's all there is for today, guys. Thank you for listening. And message me if you need anything. And good luck on your assignment.